Hello students, welcome to my channel. Today I will discuss about the chemical bonding. This is the third lesson of this topic. If you haven't watched the previous lessons on this topic, then first go and watch those videos that are already present in my channel, and then you will be able to understand this particular lesson. So let's start the lesson. In this video, I will discuss how covalent compounds are formed. In my previous video, I have already told you that when there is a sharing of electrons between two or more atoms, then covalent compounds are formed. Generally, it has been found that both the atoms that are involved in the formation of this type of compounds, both the atoms are non-metallic. That means they are non-metals. And who are non-metals? Non-metals means the elements who gain electrons. Okay. Here we will see how we are considering or why we are considering both the atoms as non-metals. Okay. See, let's consider two atoms. One X and another Y. Here what happens? Suppose this is a particular element, electron of the atom X, and this is an electron of the atom Y. So as to attain a stable electronic configuration, both an X and Y, what they will do, they will share this particular pair of electron. This is an example, okay, I'm giving. They will share this particular pair of electron. In this way, X will attain a stable electronic configuration, and at the same time, Y will also attain a stable electronic configuration. So, this sharing of electron forms a bond between X and Y. This bond is known as covalent bond, and the compound that has been formed is known as covalent compound. Now here, why we are considering both X and Y to be non-metal? Because non-metals are those who gain electrons. Here there is no losing of electrons, neither X nor Y is losing electron. What they are doing, they are sharing. That means this particular electron of X is gained by Y, and this particular electron of Y is gained by X. So here, this is a form of gaining of electrons. Though they are not fully gaining or totally gaining a particular electron, but they are partially gaining electrons. They are sharing the pair of electrons, right? That's why we are considering both these two atoms as non-metals. Okay, so this is all about the covalent compound or the bond. Now, there are two types of covalent compounds that are present. One is the non-polar covalent compounds, another is the polar covalent compounds. Now, non-polar covalent compounds means here the shared pair of electrons present between the two atoms, they are equally distributed. Okay. For example, I have given an example, X and Y. Two electrons equally distributed. Okay. Both the electrons are shared by the two atoms. So, this shared pair of electrons, they are equally distributed. And there is no charge separation. The molecule that will form is symmetrical. These type of covalent compounds, non-polar covalent compounds where the shared pair of electrons are equally distributed, there the compound is symmetrical and the compound is electrically neutral. Why? Because there is no charge separation, right? As there is no charge separation, that's why the compound is electrically neutral, as the shared pair of electrons is equally distributed. Clear? Now the example of these type of non-polar covalent compounds, I can give an example like hydrogen, then chlorine. I will discuss about these compounds later on in detail. In this particular video only I will discuss. Next type of covalent compounds is polar covalent compound. Here, the shared pair of electrons are unequally distributed. It is not equally distributed, and that's why charge separation occurs in this type of covalent compounds. And it has been found that in this type of compounds, that means in polar covalent compounds, there is slightly a negative charge that is present. Slightly negative charge is present. Okay. Example of this type of compounds is like water, then ammonia. I will show the structure. I will show how these compounds are formed. Okay, so this is basically the two types of compounds. One is the non-polar covalent compounds, another is the polar covalent compounds. In non-polar, equal distribution of shared pair of electrons we can find, and in polar covalent compounds, shared pair of electrons are unequally distributed. Okay, now let's take some examples of covalent compounds. I have taken those examples which is very common in board exams, okay, especially in Icse. Now hydrogen. Hydrogen is an example of non-polar covalent compound. That means here the shared pair of electrons are equally distributed and there is no charge separation. Okay. See, hydrogen. We know the atomic number of hydrogen is 1. Hydrogen is a molecule. That means there will be 2 hydrogen present. H2, we write as H2, right? So 2 hydrogen will be present. One H, another H. 2 hydrogen will be present. 1 and 1. So the valence electron, that means in outermost shell only 1 electron will be present in hydrogen. This hydrogen is also same. Now the nearest noble gas to hydrogen is helium. Helium has an atomic number of 2. So it has 2 electrons in its valence shell. So hydrogen will always try to attain 2 valence electron in its outermost shell. That means it will try to attain duplet so as to have a stable electronic configuration. So what it will do, both the hydrogen will share this pair of electron. This particular pair of electron will be shared by these 2 atoms of hydrogen. Okay. In this way, they will form a chemical bond which is known as the covalent bond. Clear? This is very easy. Clear? Similarly, next example is of chlorine. It is also a non-polar covalent compound. That means here also the shared pair of electrons are equally distributed. See, chlorine. Chlorine we write as Cl2. So chlorine is atomic number is 17. So 2, 8, 7. Another atom of chlorine, again 2, 8, 7. Here 7 electrons are present, right? In the outermost shell, 7 electrons are present. How we will write? See, 1, 2, 3, 4, 5, 6, 7. Let's make it as cross for this particular atom. 1, 2, 3, 4, 5, 6, 7. Now the nearest noble gas of chlorine is argon, whose electronic configuration is 288. So each of the chlorine will require another electron to attain octet, to attain a stable electronic configuration, right? So what they will do, they will share this particular pair of electron. Now see, 1, 2, 3, 4, 5, 6, 7, 8. Same for this particular chlorine atom. In this way, a chemical bond is formed, which is covalent bond. Why this is a non-polar covalent compound? Because here the shared pair of electron is equally distributed. This also shares 1 extra electron. This also shares 1 extra electron. So both the atom shares equally shared pair of electron. Okay. This is an example of non-polar covalent compound. And this is how chlorine atom is, or chlorine is formed. Chlorine molecule Cl2 is formed. Next example is of oxygen. See, oxygen is another non-polar covalent compound. Here also the shared pair of electron is equally distributed. We write oxygen molecule as O2. What is the atomic number of oxygen? It's 16. Atomic number of oxygen is 8. Okay. So 2, 6. Okay. Another oxygen atom 2, 6. Now 1, 2, 3, 4. Next is 5, 6. Okay. Again make it 1, 2, 3, 4, 5, 6. Now the nearest noble gas of oxygen is neon, whose atomic number is 28. whose electronic configuration is 2,8. So here it's 6. That means each of the oxygen atom will require 2 extra electrons to attain the duplet. I mean octet. Okay. So as to attain a stable electronic configuration, each of that oxygen atom require extra 2 electron. So what they will do, they will share the 2 pair of electron. Here 2 pair of electrons are shared. 1, 2, 3, 4. All total 4 electrons are shared. Again, this is an equal sharing of electrons by, see, this particular oxygen shares these 2 electrons and this particular oxygen shares these 2 electrons. So altogether in total they shares an equal number of electrons, right? That's why it is an example of non-polar covalent compound. Here double bond is present. Why? See, oxygen and oxygen, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. For this particular pair, one bond, and for this particular pair, another bond. So between 2 oxygen atom, double bond is present. Okay, and this type of bonding is, we all know, as there is sharing of electrons. So this is a covalent bond. Again, this is an example of non-polar covalent compound. I think it's clear to you all. Let's take another example, that is of nitrogen. Again, this is an example of non-polar covalent compound. The atomic number of nitrogen is 7, 2, 5. Let's take another atom, 2, 5. So in the valence shell, 5 electrons will be present. 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Okay. Now what will happen? See, here what happens, the noble gas that is present near to nitrogen is neon, whose atomic number is 2,8, whose electronic configuration is 2,8. Here 5 electrons are present in its valence shell. That means each of the nitrogen atom is in short of 3 electrons. So each of them will require extra 3 electrons to attain a stable electronic configuration, to attain octet, right? Because 5 plus 3 is 8, right? So what they will do, see, let's draw 2 nitrogen. 1, 2, 3, 4, 5. Let's write in this way, which will make you understand more easily you can understand. 1, 2, then 3, 4, 5. See, they will share 3 pairs of electrons. See now, 1, 2, 3, 4, 5, 6, 7, 8. For this nitrogen also, 1, 2, 3, 4, 5. 1, 2, 3. Okay, I'm drawing again. Nitrogen, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These 3 pairs of electrons will be shared. That's why triple bond is present between 2 nitrogen atom. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, for this particular nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So each of them will complete octet. Clear? So this is how nitrogen molecule will be formed. Again, this is an example of non-polar covalent compound, as both the atoms will share extra of 3 electrons. Okay. So this is the formation of covalent bond. Next example is of carbon tetrachloride. What is the formula of carbon tetrachloride? CCl4. Carbon tetrachloride means 4 chlorine will be present. So the formula of carbon tetrachloride is CCl4. What is the atomic number of carbon? Atomic number of carbon is 6. That means electronic configuration is 2, 4. Electronic configuration is 2, 4. Okay. For carbon it's 2, 4. And what is the atomic number of chlorine? It's 17. So electronic configuration is 287. Now how we will write this structure? Because here 1 carbon will be present and 4 chlorine will be present, right? So let's see. If we write carbon at the center and 4 chlorine in a rounded manner in all the 4 sides of carbon, then we can easily write the 4 chlorine atoms, right? Now what will happen? Carbon has 4 electrons in its outermost shell because the electronic configuration of carbon is 2, 4. Let's make it 1, 2, 3, 4. 4 electrons are present in the valence shell of carbon. And what is the electronic configuration of chlorine? 287. That means 7 electrons are present in the valence shell. 1, 2, 3, 4, 5, 6 and 7. Again 1, 2, 3, 4, 5, 6, 7. We have to write all these in similar manner, containing 7 electrons in the valence shell in case of chlorine. Right. Now what will happen? See, each of the chlorine atom requires 1 electron to complete the octet. Clear? Because 7 plus 1 is 8. And carbon atom requires 4 electron to attain octet. Because the electronic configuration of carbon is 2, 4. So valence shell contains 4 electrons. So 4 plus 4 is 8. So carbon atom requires 4 electron so as to attain octet. What they will do, they will share this 4 pair of electrons. And in this way, both the chlorine and carbon will attain a stable electronic configuration. Clear? See, now both chlorine and carbon have 8 electrons. See, carbon 1, 2, 3, 4, 5, 6, 7, 8. Similar is for chlorine. See, 1, 2, 3, 4, 5, 6, 7, 8. And similar for all these 3 chlorines. Clear? So this is how carbon tetrachloride is formed. We can represent this in this way. Because each of the chlorine atom shares only one particular pair of electron. That's why a single bond will be shared with each single chlorine atom. Okay, in this way we will write the structure of carbon tetrachloride. Okay, I think it's clear to you all. Now the next example is of methane. The formula of methane is CH4. Here 1 carbon is present and 4 hydrogen is present. What is the electronic configuration of carbon? I have just now told you it's 2, 4. And hydrogen, it's 1. So there are 4 hydrogens. So similarly we will write 4 hydrogen and writing carbon in the middle of the 4 hydrogen. Again carbon has 4 electrons in its valence shell and hydrogen has only 1 electron in its valence shell. Right. It has only hydrogen has only 1 valence electron. Now carbon requires 4 extra electron to attain octet. 2, 4 is the electronic configuration. So 4 plus 4 is 8. And hydrogen requires extra 1 electron to attain duplet. See, hydrogen has 1, 2, attain duplet. And carbon 1, 2, 3, 4, 5, 6, 7, 8. So in case of methane also, there will be 4 pair of shared electrons and we will write the structure as single bond in this way. Okay, this is another example of non-polar covalent compound. As in all the cases of hydrogen and carbon, only 1 pair of shared electron is present. Only 1. That's why it's non-polar covalent compound. This is how methane is formed. Next, I will give an example of polar covalent compound where there is charge separation. That means here the shared pair of electron is unequally distributed. It is not equally distributed. Here slightly charge separation occurs. Okay, and the example is ammonia. Example is ammonia. Okay, see, formula is NH3. Ammonia, the formula of ammonia is NH3. Electronic configuration of nitrogen is 2, 5 and hydrogen we know it's 1. Here 1 nitrogen is present and 3 hydrogen is present. So how we will write the structure? N in the middle and 3H at the top and on the 2 sides. Nitrogen has 5 valence electrons, right? 1, 2, 3, 4, 5. And each hydrogen has 1 valence electron. So in this way. Nitrogen requires 3 more electrons to attain octet. So it will share these 3 electrons of hydrogen, and hydrogen requires extra 1 electron. Each of the hydrogen atom requires extra 1 electron to attain duplet, right? And this pair of electron that has not take part in the formation of ammonia, this particular pair is known as lone pair. Okay, this particular pair is known as lone pair of electron. Lone pair of electron means the particular pair of electrons who has not take part in the formation of that particular structure. So here 3 pair of electrons have been shared. So the structure will be like this. Single bond will be formed as 1 pair of electron has been shared. Okay, and there will be 2 lone pair of electrons of nitrogen. Often question comes, how many lone pair is present in nitrogen while the formation of any structure? There will be 1 lone pair that is present, 2 electrons, which makes 1 lone pair. 1 lone pair of electron is present in case of nitrogen. Clear? This is a very important question, often comes. So this is all about a polar covalent compound, and I think I have made myself clear. This is how covalent compounds are formed, both the polar and the non-polar covalent compounds. I have tried to explain you in detail. So this is all for this lesson. Now I will upload the next lesson of this particular topic very soon. Till then, stay tuned to my channel. And if you think my videos are helpful and informative, then please like and share my videos. And don't forget to subscribe to my channel. Thank you for watching the video.